Is someone, oh, there we go, perfect. All right, well, thank you for inviting me to this conference. It's an honor to be here. It's an honor to be in country for the first time. I'm excited to go out and visit after this is all over. As was mentioned earlier, I'm with HDR. We have about 200 offices globally, including one here in Tel Aviv. And we offer everything from architecture to engineering to resources, water, power, transportation services. And across all of these business groups, there's a key focus to decarbonize all of these projects. But decarbonization can be an intense roller coaster. Sometimes you're up, sometimes you're down, sometimes you're feeling elated and excited about the journey, sometimes you feel sick to your stomach because you can't get everybody to get on board with you. And so I'm going to walk you through some of the pitfalls and excitements throughout this journey on a couple of projects that we've completed recently. One that achieved net positive energy and a few that just fell a little short because of these pitfalls, right? So this is the project that is a net positive energy project. It's the Orange County Sanitation District Headquarters in Orange County, California. This was a great project, about 11,000 square meters. Just completed. They just moved in a few months ago. It has a beautiful mass timber design, beautiful biophilic design elements in the space, but the journey was up and down to get there. So it started, it's in California, just here south of Los Angeles. Here's the site. It is the wastewater treatment plant, and they put their headquarters right there for all of their staff to be there. And here is the site blown up here in the building you can see with two wings oriented in east-west dimensions. And so obviously our journey to get to net zero takes a passive design approach first. Do as many things from an architectural standpoint, passive standpoint first, so that your systems can be as low energy as possible. There's a kind of a misnomer in the industry that the envelope can only get you so far. Sometimes people say 5, 10% energy savings. That's just not true. Because if you don't have an efficient envelope, you can't specify low energy systems, right, which save much more. And I'll talk about that in a little bit. And so we started, and we were really excited because the project is in California, which has the most net zero energy projects in the United States. We're like, great, this is going to be a cakewalk, right? The client wants this. We have energy codes that are going to get us there. But the very first thing that happened was we had a client PM that says, I don't really care about sustainability, which was a complete gut punch to all of us. Now, the designer for the project is Kate Diamond. She's an Israeli-American. She's about 72 years old, former IDF. Kate is a badass, and Kate does not take no for an answer. So this was the first thing Kate heard on that project team meeting, and from there, Kate was on a mission to design this the right way. And so that first lower level there, the client does want sustainability, kind of brought us down quite a bit. But we shifted gears. And I think one of the things I want to tell you guys today about lessons learned on these projects is don't say the S word. Don't talk about sustainability. There's 1,000 other things you can talk about that achieve the same goals. So we started this project through the lens of health and wellness. I've never had a client tell me, I don't want this building to be healthy. I don't want my employees to be productive. I want my employees to be thermally uncomfortable. I've never once heard that in my entire career. And so we started with, first principles, making sure we have the right floor plates at about 20 meters each to ensure that daylight is infused throughout the entire space. This is one of the only projects I've ever designed that actually had annual solar exposure, which is glare, below 10%, which is pretty hard to achieve. And all the SDA and UDI values for spatial daylight autonomy were throughout the entire space really good numbers. But this was our starting point. This was through the lens of health and wellness. And so ensuring that everybody along the perimeter had beautiful access to daylight and views, but also a reduction of glare through appropriately designed facade with solar shading. Now, the space is really nice to work in, and this was the selling point. The ideas of thermal comfort for those around the perimeter, the idea of views, the idea of reduction of glare in the spaces as much as possible. Now, we didn't tell the client that because of these items, the envelope was also super efficient, right? We were able to increase the U value. We were able to reduce peak solar gains. We didn't talk about sustainability. We talked about health and wellness initially until we got them on board with the concept throughout the process. And so, we were down, and then we came back up through the lens of health and productivity. That is a little trick that has worked for years and years, and I encourage all of you to start there sometimes with clients that aren't quite on board with this. Now, the layout of the space and that floor plate was really important. However, this is all very low energy space. Office space, conference rooms. You do want to keep all of your conference rooms and densely occupied spaces away from as many peak solar loads as possible. You want to decouple those loads, external loads and internal loads. Now, for an office building, it's pretty easy, but if you guys have higher process load buildings, like a lab building or a healthcare building, this is another good example. This is the Carbon Neutral Energy Solutions Lab at Georgia Institute of Technology, where we had a high bay lab space, which we decoupled from the extreme solar gain loads on the south. So that initial layout of program space is very important. You want to keep that space away from those external solar gains and put lower energy spaces on the south or the north, depending on which hemisphere you're in. So another good example of how we started with the first principles and the right principles in that direction. What if you have a lab building, right? It's a little, with fume hoods and you have exhaust requirements. It becomes a little harder to achieve this. So this is the Mayo Colin Research Building in Rochester, Minneapolis, just opened recently, where we took the same kind of approach. Whenever we have these high process loads in a space, we try to decouple them. So we move them towards the center of the building. We then reduce the amount of air changes required to exhaust all those lab gases, and all the perimeter spaces can then have lower air changes, right? They also then, we can cascade that air down through the space and repurpose it before it's exhausted out of the space. So talking with the design team to program the building appropriately is one of your first best steps. I would also argue that your mechanical engineer should tell you how they want to zone the building. So for the Orange County project and this project, we asked the mechanical engineer, how would you lay this out? How would you design? And they were baffled. You're like, you want me to design the space and lay it out? You're like, yeah, of course. And that's the whole tension of these talks today is like, how do we get that integration with the architect and the engineer up front? Now, once we had this program space laid out, and we knew that we were as efficient as possible for daylight and programming to reduce those high internal loads, we had to figure out, do we have enough space on site to offset the energy use once we get it down as low as possible? Sometimes that's not possible. We have healthcare projects that are constrained on a certain site, existing utility plant, and we have no extra space to put renewables. So you need to do this upfront renewables budget to determine what's possible and how much do I have to squeeze out of my building first before I offset the project. Now, I don't like this approach because there's this idea that to be sustainable, you just slap a bunch of solar PV onto a project, and I really hate that approach. It's expensive, it's not integrated, and it's a little bit lazy. This is an example from the Bullitt Center, which showed that the initial baseline design required this much PV, but if you make the building more efficient, obviously you have a smaller PV system, which costs less money. So I always say do renewables last when you're designing a project. However, you need to know what your renewables budget or your energy budget is first. So figure out from the site what production is possible on the project. And you also have to determine in that renewables budget, not just your basic energy use for the project, but if you have process loads, it makes it a little bit harder. You can't squeeze those process loads out of every building. A lab building has equipment that you're not going to get to be more efficient. A hospital has equipment that can't be as efficient as you would like it. So really understand your process loads up front. This was the Lawrence Berkeley National Lab Welcome Center. Seemingly an easy project that was just an office and conference center. However, they added a kitchen and cafeteria last minute for the entire campus. So that kitchen was about 3 times more energy intensive as the rest of the space. And a lot of that kitchen equipment could only be so efficient. We couldn't get it down further. So these process loads really dictated how much we could squeeze out of the building and then how big our PV system had to be on the other end to then offset it. So it was about a third of the overall energy use of the project. So getting your process loads understood up front, talking to the facility engineers and asking them what equipment, how often do you run it, is really important. So even though we had natural ventilation on this project, we had a lot of really great high efficiency envelope strategies, radiant systems, those process loads dictated the use of this project, and it only achieved about a 60% energy use reduction, right? So high process load buildings are a little different than low process load buildings. Going back to the Orange County Sanitation District project, we determined that the initial layout of the building allowed for about a 13 to 18% reduction in energy use with the PV system on the roof, as well as some of the parking. And that was an initial calculation, but that wasn't enough. We didn't think we could get about 82% of the energy use down in the building, so we needed to do more. Otherwise, we had to pay for more solar PV. So since we're on a wastewater treatment plant site, we realized that there was biogas and biomass just sitting there, waiting to be used. So we installed a biodigester on site, ran it through a boiler, and used an absorption chiller to capture energy, waste energy from the treatment plant to power some of the building. So I think the lesson here is that if you have process loads, sometimes you have to look beyond your project site to determine how you can generate more energy. So with these two things in mind, we had our energy budget. We knew the building had to reduce anywhere from 62 to 77% before we then offset it with renewables. So when you're thinking about your early offsets and renewables budget, sometimes you have to go beyond that project site to make things happen, especially in high process load buildings. So once we had our renewables budget and we had our layout, it was time to really hone in on the facade strategies and the system strategies. In early conceptual design, we make it a point to just show a box. I really think it's detrimental when we show clients a facade with a rendering in conceptual design. You're showing them what you're thinking about, the glazing, the openings. They then fall in love with that design, and you end up with an all-glass building. So it was really important for us to not design the facade until we got to this later stage and doing analytics. And the first step in that is to understand your peak solar load. Manage that peak solar load as much as possible so you can then specify low energy systems. Make sure your mechanical engineer helps you do the layout of your program space so you have efficient zoning of those systems, less reheat, less runs for different systems. You can then decouple comfort delivery systems and look at chilled beams or radiant systems before you do heat recovery and renewables. But these two steps are very architectural in nature, and they're extremely important to make the rest of them as efficient as possible. So when we looked at this project, we determined up front that we had a maximum of 2 watts a square foot that we wanted to let into that building facade. Any more than that, we're going to have to be stuck with a VAV system. If we get 2 watts a square foot and below, we're able to specify an active chilled beam system or even a radiant slab system or displacement ventilation. All of these low energy systems are possible if you control that peak solar load, especially in an environment like California. So that was very key. So going through parametric analysis, using tools that like Diego showed this morning, to look at different iterations of what the shading should be, what the opening should be. We kind of determined what the size of the window should be, what the size of the solar shading should be to get to that 2 watts a square foot, right? So that became the driver for us. And again, these are all recommendations. You give the data to the design principal. They then use their acumen to come up with a unique solution based upon the data. It doesn't have to look like the things that you put into the parametric analysis, but it has to perform the same way. And again, the important thing here to the client was when we talked about peak solar load was through the lens of wellness. Because we're doing this, you'll reduce glare in the space, right? We're also going to reduce energy use and talk about sustainability, but that's what we talked about internally. We didn't bring it to the client quite yet. It was all through that lens of reducing glare. And if health and wellness wasn't enough for a talking point, because of this analysis, because of that reduction in peak solar load, we were able to go from 2 chilled beams down to 1 chilled beam that was slightly larger. So this is a first cost savings. This is about $2 million in savings for your mechanical systems just through that focus on the facade. So again, nobody is going to say no to $2 million in savings of cost because you can reduce your system sizes. So it's really important to look at these system capacities to figure out how we can reduce first cost on this project. Another thing is that if we reduced and removed the shading on the project, yeah, the shading costs about $3 a square foot to install. Client wasn't happy with that. But once we removed those, we had larger ducts. We had larger fans. We had larger air handling units. We had larger chillers. So really, this was a $9 per square foot cost. So by adding solar shading to the project, we actually saved $6 a square feet because we costed the entire building. If you ever do value engineering, which I'm going to stop saying that because we need a better word for it, and people say, if you remove shading, you can save X, you're doing it wrong. You have to cost the entire building and what the shading impacts to have more holistic cost modeling for your project. So just some points of note here to decarbonize, and what we did on this project is, and this is pretty prevalent on a lot of our projects we do today, is there's a big movement away from combustion and evaporation into heat pump technology. So the project had air source heat pumps, right? We also had heat recovery chillers and ground source heat pumps in the project. If you do have high process load buildings, it's really good to have a chilled water loop, which takes all of those heat rejections and then repurposes them. So these are kind of standard net zero carbon strategies that we kind of push on all projects that we also incorporate into the Orange County Sanitation District headquarters. And at the end of the day, after all was said and done with the floor plate and the envelope and the systems, you look at this list of strategies, and nothing looks crazy. You know, nothing looks like we have technologies that we have not installed before. Nothing looks like something that we're waiting 10 years to figure out, is it going to work? All of this technology is tested, installed, tried and true. You just have to incorporate them in the right way, in the right manner, so they all work together to be efficient. And so once we had the reductions and we had our additional renewable energy from the PV as well as the digester gas, we were able to achieve an overall 105% reduction on the project. Now, it's good to note that the solar PV system was about a $3 million add, not a terrible cost, and that the entire cost of the project was $90 million. Now, that's $825 a square foot, which seems pretty high, but this is Orange County, California. And so the typical cost of an office building of this type in California is $870 to $1,000 a square foot. So we were within range of the client's financial goals, which is the most important thing in the world. So we presented this to them and said, hey, we designed this building. It meets your cost budget. Oh, and by the way, it's net positive energy and LEED Platinum. So once we presented this data, showed them how it all works, they were on board. I mean, it only took 6 to 8 months to finally just get them to say, okay, I get what you guys were doing. I understand it now. But we had to do this internally. We had to use different nomenclature to get this accomplished. And so this was the predicted model for this project, but we also had to make sure that we had the operations understood in that energy model. Do we understand what the operations are going to be for the project? So a quick lesson learned from another project, this is the Jim Pattison Center of Excellence, was supposed to be net zero, but they actually ended up being about 8% less than that, only at 92% savings instead of 100. Why did that happen? Well, there was a 53% increase in operational hours. There was a 20% decrease in PV output. Some of the solar thermal systems didn't work, and they were abandoned. And the geo-exchange pumps ran 24/7, and so we didn't understand the operations as well as we thought, and so they fell short. So it's really important to get the facility staff on board so you can understand how is this building going to operate, how many people, how many hours. We were slightly off on that project. So the Orange County project is moving ahead. So far, so good. The operations are on track, but you have to understand that beforehand. Now, just to wrap up really fast here, I want to just quickly point out the focus on embodied carbon. So this is a chart showing that the embodied carbon day one is about 12 to 15 times higher than the operational carbon. It would take 12 to 15 years for the operational carbon to match how much embodied carbon is going into this project. So this is a mass timber project. We had structural steel because California, lateral loads for seismic loads. But a very cool mass timber design, amazing details, very biophilic, and we were able to reduce the embodied carbon in the project by about 68%. Now that's assuming that the mass timber, you can count the biogenic carbon, how much carbon is stored in the mass timber, and how much carbon mass timber sequesters over its growth life cycle before you install it, making the building a carbon bank. And so at the end of the day, we had a 104% reduction in operational carbon and a 68% reduction in embodied carbon. That embodied carbon reduction was basically 12 years of operational use for this building. So it's becoming a bigger focus for all of our projects. We have about 75 mass timber projects right now, and we plan to do a lot more of them. And so once we design all these net zero energy buildings, we're going to have to shift into embodied carbon focus, right? You know, it's a whole carbon story here. And I think that it's very possible with some of the bamboo stuff we saw earlier today and other mass timber solutions. So at the end of the day, I just want to say that do not take no for an answer. And we can all achieve projects like this as long as you take no for an answer and have a badass Israeli designer on your team. So thank you.